so this is going to be objective 33. We are going to use the law of logarithms to expand expressions. Okay, to expand expressions. At the end of today, we'll actually look at condensing expressions, doing the opposite. Okay, we're going to expand it out, and then we're going to take it and put it all back together and condense it. Okay, so everybody got this part? There are 3 laws that we're going to work at today. Okay, so there's just 3 things that you need to remember. All right, so here's the first one. The log base A of A times B is equal to the log base A of A plus the log base A of B. Okay, so it kind of reminds me when you multiply powers, you add the exponents. Same thing here. So when you have 2 things, when you're taking the log of 2 things that are being multiplied to each other, you can separate them and add them together. This would be the log base A of A plus the log base A of B. Okay. Likewise, we know when we divide powers, we subtract the exponents. Okay, so if you are subtracting a log that's being divided, of 2 things that are being divided, you can say the log base A of A minus the log base A of B. And we know when we raise a power to a power, so when I have log base A of A raised to the C, what do we normally do to the exponents? We normally multiply them. So what we're going to do here is you take the exponent and you're going to throw it down in front of it and multiply it to the log. Okay? You're going to multiply the exponent times the log base A of A. Okay? And that's all you need to remember today. Those are your 3 rules. Okay? So when you're taking a log of 2 things being multiplied, you can separate them and add them together. When they're being divided, you can separate them and subtract them. And when you are raising a log to a power, you can take the exponent and multiply it. And generally, you throw the exponent in the very front and multiply it by the log. Any questions on that? Everybody good? All right. So, the log base 2 of 6x. So what's happening to the 6 and the x? They're being what? They're being multiplied. 6 times x is 6x. Okay, they're being multiplied. So if we wanted to separate them, we could separate them into the log base 2 of what? 6, then what? Plus the log base 2 of x. Any questions on that? Okay, how about the log of the square root of 5? First of all, we don't deal with square roots. You have to take it, when we're dealing with logs, we don't deal with radical form, we deal with exponential form. So you need to take that radical and write it with an exponent. So how would I write it first? Let's say the log of 5 to the 1/2 power. Okay, the root is 2, and 5 is, the exponent of 5 is 5 to the first. Okay, all right, so we know based on our rule that we just learned, if I have something raised to an exponent, what am I going to do with the exponent? I'm going to take the exponent and throw him where? In the front and multiply him. So this will be 1/5 times the log of 5. What kind of base does that have? It has a base 10. And so if you wanted to write, 1/5 times log base 10 of 5, just to make sure, but it'd just be 1/5 times the log of 5. Oh, 1/2. Thank you. Thank you. 1/2. Yeah. Throw the exponent in front. 1/2. I don't know why I have a 1/5 here. I think I miswrote it and then I fixed it. It made it a 5. So that should be 1/2. All right. What do you think about the first one? They're being multiplied and they're being raised to a power. Okay, so if we separate them, it would be the log base 5 of x to the third plus the log base 5 of y to the 6th. But what do I need to do with the third? So if you need to do it step by step, you can. First things first is I would separate it. Okay, so this would be the log base 5 of x to the third plus the log base 5 of y to the 6th. But you can't leave it like that because we don't leave it with an exponent. Okay, so what am I going to do with the exponent? I'm going to throw him in the front. So this would be 3 times the log base 5 of x plus 6 times the log base 5 of y. Any questions on that? Okay, why don't you try the second one on your own? See what you can come up with. Try the second one on your own. I would keep it ln. I wouldn't change it to log base c. Just because, yes, it does mean log base c, but we generally don't say log base c. You just say ln. Okay. Anybody want to try me out? The ln of a plus the ln of b minus 1/3 times the ln of c. How many got that? Okay. You can change ln to log e. It is the same thing. I would count it correct, but you're not going to see that on any form of test. Does that make sense? We just keep it ln. Does that make sense? We had that discussion yesterday. Yes, it does mean the same thing. It means log base e, but you don't say log base e. You just say ln. Does that make sense? It's kind of like we understand this is a positive 3. Yes, we all know that. But we don't say positive 3. Does that make sense? We just say 3. Same thing. We know ln is log base e. We just don't say it. We just say ln. Okay? All right. So my question is anybody lost? Do I need to, how can I put it all together all at once, or do I need to go step by step? Okay. I just need to know where you're at. All right. So the first thing that I would do is I would separate the numerator. Okay, so how am I going to separate the numerator? This would be the ln of a, right, because they're being multiplied, plus the ln of b. Okay, and you can keep this divided by the ln of, now instead of the cube root of c, what do we need to say? C to the 1/3 power. Does everybody understand that? The root is 3, so that is c to the 1/3 power. Okay? Now, so we fixed kind of like two things so far. Everybody understand what I did with the top? These are being multiplied. That says you can separate them and add them together. It'd be the ln of a plus the ln of b. Okay? Now, what does the division property say? It says you can take all of this and do what to it? Subtract it. Okay? So this would be the ln of a plus the ln of b minus the ln of c to the 1/3 power. And then the very last part of it would be we don't leave an exponent, so where does that 1/3 need to go? In the front. He needs to be multiplied. So it would be the ln of a plus the ln of b minus 1/3 times the ln of c.